Okay, so the stupid audio microphone stopped working again. Let's see here. We were talking about reordering the constraints to move P2 instead of P3. So I've completely reordered these, changed the directions and everything, so everything is pointing as much as is reasonable away from P2. And we've gotten our 2 degrees of freedom, and that's all we need to move a point. So now if we move this point, we could move it as a rigid body. But that's how we reordered constraints to move a point. So anyhow, everything's still yellow, under constrained in the fact that there is no properly constrained point. We need properly constrained points to change something from being a rigid body to fully constrained. So it's a rigid body, but it's not fully constrained. And what we need now to fully constrain it is a connection to ground. So on this next one here, I've shown a ground here, mechanical ground, and we're going to fix P2, the x and y coordinates. So we draw a dependency from ground to P2. And now anything, this is now properly constrained because it's constrained to ground. So we change the color to green, so it's properly constrained. Now any scalar now that a properly constrained scalar points to, or that it is constrained to, becomes properly constrained. So as we can see, all the arrows point now to everything, and everything is pointed to by a proper constraint, or a properly constrained scalar. So it's properly constrained. Now if we were to grab and try and move something, it shouldn't move, it won't move, because it is all properly constrained. So fully constrained, no degrees of freedom remaining. Unlike up here, where we could change everything around and have still 2 degrees of freedom left. And that's all. Okay? So now moving on, originally, in this drawing here, we had a length constraint here. Well, what if we chose to have a length constraint instead from P2 to P4? Well, that's a fairly easy thing to switch. We're going to change this constraint here, this L2 constraint, and we're going to draw it. Now, we're just going to illustrate this real quick. Suppose we had originally chosen to draw it this way. And, well, we've got 2 arrows here pointing at this one. But we say, well, perhaps we can reorder this other one to meet this constraint. But anyhow, if we follow this back, we'd have to reorder this direction to point to P1x here, and we'd have to change this direction here, go back to P2x, and we cannot do that because we cannot change the direction of this arc. We can't define ground by another parameter. Ground can only define other things. So we'll see that that's not possible. We'll see. Well, then what we need to do to resolve this constraint problem is to change the configuration of this length constraint. So say instead of pointing to P4x, we could change it to point to P4y instead. Now this is good, because now everything is properly constrained. Only a single arrow pointing at any scalar, so that's properly constrained. So we can fix constraint problems by changing the configuration of a constraint. Okay? So this is getting really boring. I'm sure everybody's sick of hearing this by now. But anyhow, now what happens if we delete that length constraint completely? So it's under constrained by 1 degree of freedom remaining. So if we think about this top corner's fixed. This is horizontal, it has a length, and these 2 sides are vertical, and this is horizontal. If we're thinking about this, if we were to grab any point, the only points that we could move are P3 and P4, and they would move vertically. And we'll see that that makes sense. This is drawn the wrong way. Let me fix it real quick. None here. And there. Okay, so this is under constrained, right? And we'll see that here's our extra degree of freedom, but we'll see that this depends on it. So when we change this one, we expect this one to change. So when we're sending things to the solver, we're trying to do 2 things here. We're trying to give the user feedback on whether the sketch is under constrained, over constrained, or exactly constrained, and then we're also trying to reduce the computational expense of solving constraints, especially as things get bigger and more interdependent constraints. So anyhow, the only thing we need to send to the solver to solve this problem, if we, say, tried to move P3, the only thing we'd send to the solver is P3y and P4y as parameters to change, and this horizontal constraint is the objective function. That's all that we need to send to it, assuming that everything else had previously been solved correctly. So that reduces the computational expense here. Now, if we wanted to move P4, we would try and point this away from X, but we notice we can't change it. But we'd also change the direction of this dependency. Let's go down here and change the direction of this dependency. So we're going to switch the direction it's going back to the other one. So now, I'm not going to change the colors here, you can imagine. So now P3y depends on P4y. So once again, the only thing that we send to the solver is P4y, P3y, and the horizontal constraint, and it'll solve it. So anyhow, this is really simple, just lines and horizontal, vertical, and length constraints. It'll get a little more complicated as we do arcs and constraints that have more than one degree of freedom, like point-on-point or collinear. Some of those constraints that have more than one degree of freedom that they take away. But I think that this will get us on the ground running. This does the things that we want it to do. It reduces the computational complexity of the problem, so it should be faster and more responsive on sketches where, especially where there's different parts of the sketch that don't depend on each other at all. As well as it provides us the information about where degrees of freedom are, if something's under constrained, exactly constrained, or over constrained. That's very important that we give the user feedback on that.